It's a sunny Saturday morning in Wallops Island, Virginia at NASA's Wallops Flight Facility, and you're looking at a live view of the Mid-Atlantic Regional Spaceport Pad 0A. What you see right now is the Antares rocket with the Cygnus spacecraft ready for launch in just under 30 minutes on Northrop Grumman's 12th commercial resupply mission to the International Space Station.
Copy that, FSO and Ops 1, Step 3.
Cygnus will be delivering over 4 tons of cargo to the International Space Station, and after its launch today, it'll make a 2-day journey, arriving Monday, November 4th.
FGS external power nominal. Copy that. We'll check 356 and 357.
I'm NASA's Leah Cheshire, and we're live from the International Space Station Flight Control Room at NASA's Johnson Space Center in Houston, Texas, where flight controllers are monitoring all systems aboard the space station.
Step 359, transfer
Over the South Atlantic, southwest of Cape Town, South Africa, at an altitude of 257 statute miles. But down here on the ground, and as you can see in this picture, mostly clear skies, actually totally clear skies, and a little over 40 degrees Fahrenheit. Expecting nice and clear conditions throughout the rest of the morning. There is a 0% chance of any weather violations. Cygnus will arrive to the International Space Station after a 2-day journey, and it will make its way to the Unity module on the Earth-facing side of the station Monday, November 4th. Astronauts aboard the station will use the Canadarm2 to reach out and grapple the spacecraft once it reaches its grapple point. Jessica Meir will be the capture lead for that morning, and she'll be backed up by Christina Cook. NASA astronaut Drew Morgan will monitor Cygnus systems during the final stage of the rendezvous. Once astronauts have captured the vehicle, they'll turn controls back over to teams here on the ground, where the robotics officer will use the Canadarm2 to reposition the spacecraft and bring it up toward the Unity module and berth it with the space station. Crew will access the cargo later that day. And Cygnus will remain attached until January 13th, 2020, when it will depart the space station but not return to Earth just yet. It will complete some satellite deployments and additional objectives before burning up upon re-entry into Earth's atmosphere.
Prop 2. Yeah, Prop 2, Step 365. You go to place OCCS in the SAC mode and pause the HSS ASC.
In work.
Under 24 minutes until launch this morning, let's take a look at what is on Cygnus. A total of over 4 tons, over 8,200 pounds, will be launching to the space station this morning. That's over 1,700 pounds of crew supplies, over 4,242 pounds of utilization equipment, which is science experiments and other hardware, 203 pounds of spacewalk equipment, another 1,561 pounds of vehicle and system equipment, and 31 pounds of computer resources.
Lead and Prop 2, you can resume your HSS ASC and then return OCCS to automatic control mode.
And LC Prop 2, HSS ASC resumed, OCCS in auto control mode.
Copy that, too. We'll check 368 and 369 and GNC1. Can you provide?
My team and I work to increase the focus on clear requirements development, interface design, testability, and verification. The system engineering is an important role to Antares as we actually get to, interface with all the different engineering disciplines through across the program. And we do this to ensure that we are always in compliance with our customers' requirements and their needs throughout the program.
That's great. So there are some differences with this launch that we saw this before on Northrop Grumman 11, but we're seeing it again on Northrop Grumman 12, the late load option for cargo on Cygnus. Can you tell us a little bit more about that?
Sure. One of the unique features of the Antares 230 Plus vehicles is that we have built new specialized ground support equipment that allows us to take the vehicle from vertical to horizontal. This allows us to kind of drive what we call a mobile clean room right up to the pad, as you see that there in the graphic. And this allows us to remove the pop-top fairing. We can't see it there in the picture, but there's actually a pop-top on top of the fairing that comes off. And we're able to load time-sensitive research experiments and other perishable items that NASA needs to provide 24 hours prior to launch. I'd also like to note a key flexibility feature added to the CRS-2, which is the ability for NASA to significantly alter the final cargo load by up to 20% as late as the 24 hours before liftoff. And you can't see it here too, but there's a bladder that inflates between that little opening there and the fairing, and that inflates to close the gap between the clean room and wall so that everything that goes in and out is protected.
Officer LT, countdown 1, step 94. Let's go ahead and initialize the ground ordnance power supply.
Ground ordnance power supply is initialized.
Ground ordnance power supply is initialized.
LT, prop lead, countdown 1, VTSO activation verified.
Copy all there properly. We'll check 393, 394, and 395. T-minus 1 minute. Mark.
Range is green, weather is good. 40 seconds until launch.
T-minus 30 seconds. Mark.
$20 seconds until liftoff.
T-minus 10. 5, 4, 3, 2, 1.
Lift off of Antares, NG Club mission, Wallops Flight Facility. Engines at 100%, attitude nominal, power nominal. Engine performance nominal, attitude nominal. Or pressure nominal. Power nominal. TBC performance nominal. Engine performance nominal. Estimated alpha, 1 degree. BNO3 is open. Engines remain at 100% and steady. Beginning of load relief. Power is nominal. Estimated alpha 1 degree. Engines remain at 100% and steady. Power is nominal. Load relief phasing out. The NG3 is open. Roughly 100 seconds to MECO.
Everything proceeding smoothly, about 100 seconds till main engine cutoff.
Just passing 100,000 feet. 100 feet per second squared. High altitude pitch up at 5 degrees. Enabling velocity steering. Engines remain stable. 1 minute to MECO. Engines remain at 100%. Attitude is nominal. VNO4 and VNO5 activated. Power nominal. Just passing 200,000 feet. Slow throttle down to 80% initiated.
Main engine cutoff coming up in about 15 seconds.
Engines 55%. Engines remain nominal. Main engine cutoff, nominal. PSS disabled. Stage 1 separation. ACS enabled. Attitude nominal.
You can see in this graphic, Cygnus is separated from the stage 1, and in the next few seconds, we'll be looking for the fairing separation. That's the shroud that covers and protects Cygnus during its launch.
Stage 1 ignition time projected at T plus 245. Fairing separation. Interstage separation. Stage 2 ignition.
Stage 2 is that solid rocket fuel that will burn for about 2 minutes and 43 seconds.
Attitude nominal.
Everything proceeding smoothly for Cygnus.
Nominal. Avionics power is nominal. Reaching 135 kilometers. Attitude nominal. Stage 2 TVC is nominal. Power subsystems remain nominal. Altitude has just reached 150 kilometers.
Stage 2 continuing to propel Cygnus now at 1,100 miles per hour.
Power and TVC systems remain nominal. Attitude nominal. We are nearing 1 minute to stage 2 burnout. TVC is nominal. Attitude nominal. Altitude 180 kilometers. Power subsystem nominal.
Stage 2 burnout coming up in about 30 seconds. Cygnus velocity currently over 15,000 miles per hour.
Spacecraft separation.
Team celebrating the confirmation of the spacecraft separation. Cygnus is now flying on its own.
Maneuver initiated. LC, that will end our callouts here for the NG-12 mission for Antares.
Excellent job, Ace. Excellent job. Good launch all the way around. Let's go ahead and continue with our post-launch checklist on countdown 1. And prop 1, step 423. Can you give me status on pulse purging?